In this video, we will do 6 questions about verifying. Okay, how do we verify identities? That means from left-hand side to the right-hand side, we need to show logical flow so we can provide the left-hand side is equal to right-hand side. That is verifying or proof, okay? Proof. So that is going to be done in 6 questions, and I have reciprocal identity and Pythagorean identity in this lesson. If I'm using more different kind of identities, it is also possible in the future, okay? So let's check how we get left-hand side, right-hand sides are equal to each other. Question number 1. Okay, if this is the question, what is the first step? So I see Pythagorean identity here right away. Do you see it? Square sine, square cosine. Sum is 1, right? So next step will be replacing that with 1. So left-hand side is going to be 1 over cosine theta. By using reciprocal identity, next step will be secant theta, which is right-hand side. So what is the correct answer? Replace this on the left-hand side of the equation with number 1, because that is Pythagorean identity. Okay, so I use the Pythagorean identity in the first step. Make sense? Okay, next one. If you're asked to verify this identity, what would you like to do? So let's see, cosine theta, secant theta. So left hand side, I'll start with it, okay? Cosine theta, secant theta. Next step, I'm going to use a reciprocal identity. What is a reciprocal identity for secant theta? That's right, that is 1 over cosine theta, right? So I replace that part. And then let's simplify. Oh, I forgot writing theta. These two canceled out, so we have 1 only, that is right-hand side. So proof is done. So what will be the good thing to choose? We replace secant theta on the left-hand side with 1 over cosine theta. So that is the step, okay? Make sense? Oh, next problem. All right, question number 3. Let's see the question. Sine theta, secant theta is going to be equal to tangent theta. So let's see. What would you like to do on this one? So let's say left-hand side. Sine theta, secant theta. So we know the definition of the secant theta from reciprocal identity. So let's replace it, okay? That is 1 over cosine theta. So this is what I did first, all right? And then next step will be, okay, put them together, sine theta over cosine theta. What is that? That is tangent theta. Is that right-hand side? Yes, so we can finish the proof, okay? So question, what is the most likely the first step? Okay, so we will choose the correct answer. We replace secant theta on the left side of the equation with 1 over cosine theta. That's what we did. So we are using definition of the secant, cosecant, cotangent. So we can simplify with the terms, and so we can have the right-hand side, okay? Next one, number 4. If you're asked to verify this one, what would you like to do? That's right, I'm going to exchange this one, right? Instead of cosecant theta, what would you like to put? 1 over sine theta? 1 over sine theta. And then what do I get? Cancel, cancel. And then what is the answer? Answer will be 1, right? All right, now let's look at carefully. Replace sine theta, cosecant theta, cosecant theta. Cosecant theta is not that, right? And we don't replace that. We don't replace sine theta. So this is the best option. You cannot verify this identity because it is not true. What is the right hand side? When we simplify, we have 1. Okay, so the number 4 would be a little bit tricky. You try to make it true, but it was not true, so we cannot verify it. Next question, number 5. The verification is listed in order, so this is the proof, okay, or verifying identities. So let's see, left hand side. Instead of this, we have this, right? So replace this with that, that's right. And then cancel, divide out. Okay, so we have 1 on the left-hand side. Where did the student make a mistake, or is the student correct? So let's see. Anything is a mistake? Okay, let's start with the checking, okay? Sine squared of x plus cosine squared of x equals to 1. That is Pythagorean identity. So let's try to leave 1 minus cosine 1. So I'm subtracting cosine squared of x, okay, from both sides. So 1 minus cosine squared of x will be sine squared of x, right? 1 minus cosine squared of x is sine squared of x. Oh, what's missing here? Yeah, second power is missed, right? It should be second power. Make sense? And then when you, after that, that is all error, right? Because we made a mistake at the beginning here. So let's see. Choice A, 1 minus cosine squared of x should have been replaced with sine squared of x. That's right. So this is the correct answer. That was the mistake. From that mistake, we have a wrong proof, okay? If you want to try the correct proof, this will be sine squared of x over sine x, which will be canceled out. So this will be 1 over sine x, which is cosecant x. So this is equivalent to the given left-hand side overall. Make sense? Okay. Next one, last one. Verify. Okay. So cosine, and let's read from here. So let's check that from the sine squared of x plus cosine squared of x equals to 1, Pythagorean identity. And I have this and only that. So can I move this over here? So by subtracting 1, so let's write it, sine squared of x, subtract 1. And I'd like to move this term over here by subtracting cosine squared of x, okay, on both sides. So this will be equated with negative cosine squared of x, not just positive 1 here, okay? Oh, okay. I hear a loud noise from somebody else. Okay, all right. So that will be correct choice, right? This student made a mistake from this beginning. This should be negative squared of negative cosine squared of x. And then left-hand side goes like cosine x over negative cosine squared of x. So you can cancel one of those. So this will be negative 1 over cosine x. So this will be negative secant x. So the right hand side will be the same as this. So this is going to be the proof. Okay, so showing left to the right hand side is verifying the identity. And in this problem, we have a big mistake because of the little things sign in front of it, okay? So from Pythagorean identity, we arrange the terms to have the equal expression. So don't forget this negative sign in front of it.